All right, so parametric equations. Parametric equations are about relationships and how things are connected. Do they move together or apart? And maybe they're like completely independent. So this is what we're going to talk about. These are called parametric equations. So normal equations assume just one input to one output kind of connections. For every x, there's a y and things like that. So, we plug in x equals 3 into some relation. Let's say y equals x squared. Well, if x is 3 squared, well, then y would be 9, right? But is that the only way, right, to see this scenario? Could it be that y just happened to equal x squared, and maybe there's some other hidden factor that's changing them both, right? So this hidden factor would not only change x to 3, but it also changes y to 9. Let's talk about it maybe with the different type of example. Let's look at ice cream and temperature. So let's say for every degree above 70, the convenience store sells X bottles of sunscreen and X squared pints of ice cream. Could we write the relationship as ice cream equals sunscreen squared? Well, for every degree above 70, I am selling one ice cream to two, right? Or one bottle of sunscreen to two things of ice cream. And is it correct? Yeah, but it is misleading. So that equation implies that sunscreen directly changes the demand for ice cream when it's kind of a hidden variable of temperature. The temperature is what changes them both. As the temperature goes above 70, the amount of sunscreen needed increases, and the amount of ice cream sold increases or is squared. So with parametric equations, they help us get closer to what the real world relationship is. So for example, ice cream and sunscreen. As one goes up, the other goes up squared. Well, what is it really? Well, it's temperature. And you have to isolate that parameter, that temperature parameter, so that it's not ice cream compared to sunscreen. It's ice cream compared to temperature and sunscreen compared to temperature. And that these are both changing based on this other variable. Let's take a look. So let's start slow, okay? It says find the ordered pair that corresponds to these parametric equations. So the first thing to notice is that what? It says, well, first, here, let's back up a second. The x equation has a t, and the y equation has a t, and fun for us, they told us t is 2. Awesome. All right. So what am I going to do? Well, I have a variable that has a value, so I should probably plug it in, right? Okay. So t equals 2. So that's x equals 4 times t is 2 plus 3. X equals 8 plus 3, or x equals 11. Okay. Now we're going to look at the y part. All right. Again, we're plugging in. T is 2. So I've got y equals negative 3t, well, t is 2, plus 1. So y equals negative 3 times 2, that's a negative 6, plus 1. So y equals negative 5. Oh, okay. So, ordered pair, x, y. X is 11, and y is negative 5. Beautiful. These two equations, x and y, are both changing on that variable t. All right, so it wasn't too bad. Let's take a look. Let's take a look at another one, but maybe step it up just a notch, right? Let's talk about some curves. So let's say that we want to graph this curve, and we've got x equals 4 cosine t. Again, there's a variable. And y equals 4 sine t. Okay, there's that variable. And t is basically anywhere from 0 to 2 pi. All right. That's not bad. So anytime you see something like this, 0 to 2 pi. You want to think about your four corners. So you've got 0, 90, right? Pi over 2, pi, 180, and 3 pi over 2, you're 270. So you want to think about in those terms. So here I've got, this is my equation, and these are the values I'm going to plug in. And we're going to plug in all four of these: 0, pi over 2, pi, and 3 pi over 2. Okay, let's start with 0. So I have 4 cosine of 0, because I'm saying t is 0. Well, cosine at 0 degrees, or cosine at 0 radians, do you remember it's the ordered pair, x, y, cosine's the x. If we're on a unit circle, the x is 1, and so you've got 4 times 1, so that's a 4. Oh, okay, so that's my x, and let's figure out y. Y is 4 sine of 0. Okay, so it's 4 times, again, thinking about the unit circle, sine of 0 degrees, 0 radian, that's the y, the ordered pair at the y. Let's see, on the ordered pair, unit circle, that would be a 0. Oh, so it's a 0. So that means my ordered pair for this one, when I plug in 0, is 4, 0. Okay, let's do 90. Right, pi over 2 is 90 degrees. And the ordered pair at 90 degrees, let's just go ahead and write it. It's going to be 0, 1. Right, if you go back to the unit circle. So I've got 4 cosine t, but t is pi over 2, which is 4 times cosine is the x. The x is 0, so that's a 0. Here I've got 4 sine of pi over 2. 4 times sine is the y, so it's 1, so that's a 4. So that means that my xy here is 0, 4. All right. Let's do, we got 2 more to do. We got 180 and we got 270, pi and 3 pi 2. All right, so pi, which is 180 degrees, ordered pair is a -1, 0 on the unit circle. So we've got 4 cosine pi. That's 4 times, that's the, cosine pi is the x coordinate at pi, so it's -1. That's going to give me a -4. 4 sine pi. That's going to be 4 times. Sine of pi is the y coordinate at pi, so that's a 0. So this is going to give me an xy of a -4, 0. Oh, right, we've got 2 more actually after this because we've got to go all the way around. All right, 3 pi 2, which is 270 degrees. 270 degrees. Think about your ordered pair. This is where you are, okay? Your ordered pair here is 0, -1. So I've got 4 times the cosine of 3 pi 2. Well, that's 4 times, cosine's the x. So I get me 0. Here I've got 4 sine of 3 pi 2. That doesn't look very good there. Try it again. That's 4 times the y. It's going to be a -1. So this actually gives me a -4. So my ordered pair here, xy, is a 0, -4. 2 pi, which is 360 degrees. We're back at the, the 0, if you will. 0 degrees, 0 radians. It's the same location, but you've gone around one time. So we're at 1, 0. So 4 cosine 2 pi is going to be 4 times 1. That'll get you a 4. And 4 sine of 2 pi, I can't write, is 4 times 0, get you 0. So that means I'm back to 4, 0. So let's plot all of our points. Let's write them all out. If you'll remember, our first one was a 4, 0. Let's go back up and look. Our second one was a 0, 4. Our third one, negative 4, 0. And our last one before we hit that full rotation is 0, negative 4. So basically, let's look at this. We're going to graph these. And you know what it's going to look like. 1, 2, 3, 4. 4, 0. 1, 2, 3, 4. 0, positive 4. 1, 2, 3, 4. Negative 4, 0. 1, 2, 3, 4. 0, negative 4. This is a circle. It's a circle with radius 4. And we kind of should have figured that one out because we are working with trig functions, obviously, and we're going around the unit circle, finding our values. Let's try another one. It says find two different parametric equations for this equation. So basically, what are you doing? You're taking an equation that has a y and an x, and what do you want to do? You want to basically come up with two equations that have this so-called lurking variable, this, unidentified variable, and we're going to call it t. And then we'll go from there. So the first thing is, okay, let's just replace x with t. Because if you'll go back up and look, let's go back just, where was the one we had? Here, look. X was an equation with variable t, y was an equation with variable t, and we had a value for t. That's kind of where we're going here. All right, so y equals t to the 5th plus 4. Okay, great. That's not bad. Now what are we going to do? It says now try substituting in t to the 3rd for x. Okay, well, let's just do what it says. Y equals t to the 3rd raised to the 5th plus 4. That would get me to, oopsie, t to the, remember, exponent to exponent, you multiply. You remember a to the m to the n equals a to the m times n? If you remember that. It says good job. That was what this section is about. It's about taking two equations and adding a parameter for t. We say time. Lowercase t is time. So what about eliminating the parameter? So this time we've kind of got, we've got two equations. Again, they're just linear equations. And we've got this value of t, which is basically any value. Lovely. Okay. So let's take a look. So first thing, what are we going to do? Step 1. Let's say solve for t. And then we're going to substitute basically that value into the y equation. This one's really nice because it's already done for you, but, So basically solve for t. Oh, look, it's already solved for me. Oh, how lovely. And then we're supposed to take it and plug it into this equation. So you go, oh, okay, well, y equals negative 11t, but t is x, and you're done. There's no restrictions on this one because of your original equation. Let's do one that's just a little bit harder. Let's take a look at this one. That one was nice and lovely. We're going to do a little bit harder. All right, first step. First step is the same. We're going to solve for t. That means that I need to take x equals the square root of 2t, and I need to solve for t. Well, first thing you want to do is, oops, my bad. Let's try this. What gets rid of a square root? Well, if I square both sides, I know that that will cancel. Oh, okay. And now I'm almost done because I want t by itself. So this is just going to be x squared over 2. So now what am I supposed to do? I'm supposed to take that value and plug it in, right? I'm supposed to plug this into the y equation for the value of t. Well, y equals 2 times x squared over 2. Minus, I think that's a 7. All right. Oh, Well, that's nice. The 2's cancel. So y equals x squared minus 7. Ah, okay. So there is my equation. The problem here is we have to talk about restrictions. Ooh, restrictions. All right, talk about restrictions. Go back and look at this one. There's a radical in our equation, and radicals, you cannot put negatives in under radicals. So basically the restriction is that this is only valid for positive numbers. Right? Because you can't put negative values in here. You can't have the square root of a negative. Let's talk about another one. This one's kind of a little bit trickier and kind of ugly. So we've got x equals 19 sine t. All right, well, let's just start with step 1, and I want to solve for t. Hey, okay. 19 sine t. That's 19 times sine t, so let's just move the 19 over. Okay, it's getting better. When I want to move, right? When I want to move a value from one side to the other side, but yeah, let me think. Let me start again. Okay. How do I want to say this? Okay, let's talk about it this way. We're not going to isolate the t value by itself because it's sine t. It's not it's not just a variable I can just isolate. It's sine of t. Okay, so when this is the case, you want to isolate it both. All right, let's go ahead and isolate the trig function for both. So y equals 19 cosine t. So y equals 19 cosine t. Okay, we're getting there. All right. So now we have to use a little bit of a trick, of a trig identity. Everybody loves trig identities. What do I have? I have sine and I have cosine. And the one trig identity I know is that sine squared plus cosine squared. It's going to get me a 1. So what I can do now is, because I have sine to a linear function and cosine to a linear function, I can actually plug these in. So instead of sine squared, it's x over 19 squared. And instead of cosine squared, it's y over 19 squared equals 1. Oh, okay. Well, if you remember properties of radicals, a over b quantity squared, it's just a squared over b squared. So I get to square top and bottom. Oh, that's nice. So I got x squared over 19 squared, and then y squared over 19 squared, right? Let's go ahead and move the 361. It's being divided on both sides. Oh, it's being divided like this, yeah? So if I wanted to get rid of it, I would just multiply both sides by 361. So it would cancel with the denominator here, it cancel with the denominator here, and then that would be 1 times 361. So what do I end up getting? I get y squared plus x squared plus y squared equals 361. Wait a minute. 361 is 19 squared, so that's x squared plus y squared equals 19 squared. This is a circle with a radius 19. That's supposed to be a 9. That doesn't look right. You guys know what I'm trying to say. There we go. Okay. If it's a circle with radius 9, we have to talk about the restrictions. Well, if it's a circle, right, x can go from negative 19 to positive 19, and y can go from negative 19 to positive 19. Not too bad. Not too bad. Let's take a look at this one. Gonna have to use the same kind of thing. Remember, x equals 4 secant t. I can't get t by itself. It is a trig function. So I have to isolate the trig function. Same thing here. Y is 7 tangent t. can't get t by itself. I have to get the trig function, okay? All right, so we want to think about a trig identity that uses secant and tangent. And, I mean, you could use a couple of different ones. We have secant squared theta equals 1 plus tangent squared theta. I like this one because it has a 1 in it. Anytime a trig function has a 1 in it, it's kind of nice. We're going to use this one. So the first thing we're going to do is we're going to start the same way as before, is we're going to isolate those trig functions. So x equals 4 secant theta. So x divided by 4 equals secant. I'm sorry, I meant to say secant t. We're going to say the same thing with the y. That's 7 tangent t. So y equals, there we go, y over, I'll get there. Here we go. And I'm trying. Y over 7 equals tangent t. Okay. So now what can I do? Well, I have a trig function right here that uses these two values. So secant squared, we're just going to write t, equals 1 plus tangent squared t. I know secant is x over 4. So that's x over 4 quantity squared equals 1 plus, I know tangent is y over 7. So y over 7 squared. Again, a over b quantity squared means I get to square the top and I get to square the bottom. So I have x squared over 16 equals 1 plus y squared over 49. Okay, so let's think. Let's get the y on the other side. So both variables are on one side. Oh, okay. So what is this? Okay, this is not a circle. No, because they don't have the same denominator. We have two squared variables with a subtraction in the middle equal to 1. That means that we have a hyperbola. So we can actually graph this. Remember, a hyperbola is, let's see, it's x squared over b squared minus y squared over a squared, right? Okay, so we can draw this. So we've got that hyperbola. All right, good deal.